Hi, so I'm going to talk about our Unilever project in our senior seminar in economics class and what I did in response to this project, trying to solve it. So basically what's going on is that there is this manufacturing kind of equipment where on one end there is a mix tank which produces this kind of liquid beauty shampoo type materials, and then on the sides there are these relay tanks that hold the material, and then finally there is this line that runs the both of these three tanks into the bottles that are going to be sold. So the thing that Unilever wanted us to do is to try to calculate the times at which both these two processes are operating. So the mixed production times and also the line times. So the thing they were mostly concerned about is how often the lines were going down because they were faster than the manufacturing processes going on within the mix tank. Every time that the line is not operating for every hour, it costs the plant $1,000. And if that happens enough, then maybe it might justify buying a new mix tank if it costs something like $1 million. And so basically how I went about this problem is that I tried to recreate a schedule of what was going on inside these factories, what was going on between these mix tanks and these lines, these processes. And so the first step to me doing that required trying to calculate how long it took to fill these bottles. And to do that, I had to convert the batch size from 16,800 pounds to about 268,800 ounces. From there, I had to divide that many ounces, the batch size, by the bottle size, which for line 1, for example, was 3 ounces. And then I had to divide that by the operating line efficiency, which was either 200 bottles per minute at 50% or 400 bottles at 100%, in order to get the amount of time in minutes it would require to run that line. So for example, for line 1, I figured out that just for at the 100% operating line efficiency, it required about 3.5 hours, whereas what the 50% required about 7 hours. And then I had to think about, how much do I do of each batch? And I tried to do it roughly equal, though I didn't always make them equal because some batches take longer or some take shorter, but I made them roughly all about the same size. So for example, line 2, I had them each have 5 batches, and in the end this would make up 120 hours of operations. So now I'm going to go through what I actually found. So for line 1, I found that the line was actually slower than the manufacturing at 50% capacity and at 100% capacity. So line 1 at a 7.47 hours for filling time was actually less than what could have been done at a speed, more could have been made. And this was because the mix tanks were usually faster. I think the slowest for line 1 was something like 6 hours. And so as a result, there was actually another problem I found whenever you were doing this, and that was that there actually weren't enough relay tanks. You'd have a process where not all of the batches would be transported into the bottles, but there would still be time for manufacturing going on. This was especially an issue whenever you were transitioning from one batch to the next, because you couldn't mix the batches. So you couldn't have one batch with another batch in one relay tank. You would have to separate them out. So it would make it so that you would have to stop manufacturing and wait until some of that product was put into the bottles. Because of this, not all of the batches were actually made in line 1 at 50% or 100% capacity. In fact, you had to cut some of them short at the end because they were having to freeze manufacturing so much. Then you get to line 2 and line 3, where you have this other unique issue where there are different bottle sizes, which means that the line process takes different times for every single different batch. And this made it even more complicated, this transition from batches, because once again now you had to have these sometimes long line times move into other manufacturing times. So while maybe you are manufacturing batch 2, maybe you're still filling batch 1. And as a result, this created some more congestion within the relay tanks and in the batches. For example, this was especially an issue in line 2 when there was a 7.54 hour time required to fill for batch 2. And for those 3 lines, there was not ever a point where the lines were manufacturing without any material to make. There was always something going on. And so the concern about having downtime with the lines wasn't really relevant to those first three lines. Until you get to line 2 at 100% capacity and at line 3. And in these instances, there are times when the line is needing material. There is times when the line is down because there's not enough stuff being manufactured. So, for example, in line 2 at 100%, there's this instance where there's only about a little over an hour required to fill in these bottles, but that it takes 4 hours for the mix to makes the material. And so, as a result, you have times when there's a lot of downtime. So for line 2 at 100% capacity, I found that there was 26.7 hours of downtime, which made for $26,700 in costs. This was similar for line 3, which was much faster than all the rest of them, such that one point there's a mix tank that takes 6 hours to manufacture material, but the line at just 50% capacity works at 1.7 hours is only required to fill in the products into the bottles. And so there's 29.08 hours of downtime in line 3. This makes for $29,080 of cost to Unilever. And so from my analysis with the schedule, I've kind of identified 2 different problems that you kind of have in this manufacturing equipment. One is that there isn't enough relay tanks. There is manufacturing that is happening, but not enough of a quick enough line to put them into the bottles. And that is the case for all of line 1 and line 2 at 50% capacity. And then there's this other situation where the lines aren't fast enough, where there's manufacturing that's taking place in the mix tank is all being taken out and put into the bottles. And as a result, the line is just sitting there not doing anything and costing $1,000 an hour. That is true for line 2 at 100% capacity and for line 3. And now we get to this question of, when is it worth buying another mix tank, something that would be faster, that may be able to accommodate these quick line times. And that is whenever there is $1 million worth of downtime and costs. So for line 2, I calculated it. So it requires 38 weeks of downtime for line 2 at 100% capacity to produce $1 million worth of costs, whereas in line 3, that number is just 34 weeks. These are the only 2 situations when a new mix tank would really be viable, whereas the other 2, they didn't give us a cost of not being able to produce as much during the day, of not having as much productivity per week because of these clogged relay tanks and clogged manufacturing mix tanks. But that is a problem too, because it's not being able to produce as many batches per week as otherwise Unilever might want. And so that is my suggestion to look into these 2 problems. I appreciate you listening to my presentation.